Okay, in this video, we're going to be doing Calc AB Problem Set 125. The problems and a playlist are in the description below. Let's take a look. Find the particular solution to the differential equation dy dx equals 1 over the quantity x minus 4 squared with y of 0 equals 5. All that means is solve the differential equation. So I'm going to treat this like a separable differential equation, although you might be inclined to just integrate and solve for c, which there's nothing wrong with that. I'm going to rewrite it as x minus 4 to the negative second so that I can do plus 1 times the reciprocal. But first, I'm going to separate, right? So I'm going to leave dy on one side, bring dx to the other side, and get this. Throw some integral signs in here, which I often forget to do. On the left-hand side, I just get y. On the right-hand side, it's plus 1 times the reciprocal, so that's going to be negative 1 times the quantity x minus 4 to the negative first, but I'll rewrite that as just 1 over x minus 4 plus c. Now we have to solve for c, so y of 0 is equal to 5. So 5 is equal to negative 1 over negative 4, which is positive 1/4. So you get 20/4 minus 1/4 is 19/4. So I get c is 19/4. Therefore, I'm going to say that y is equal to negative 1 over x minus 4 plus 19 over 4. I forgot to do this. I think that I should go back and actually add in the domain restriction because our solution needs to be continuous on an open interval that contains the initial condition, right? So 1 over x minus 4 has a vertical asymptote at x equals 4. I need to either be less than 4 or greater than 4. Since I need x to be 0 and 0 is less than 4, we will say x is less than 4. So I should have done that initially, but I forgot because I'm the only one making these answer keys. All right, let's look at the next problem, which hopefully does not have the same issue. Find the particular solution of the differential equation in dy dx equals quantity y plus 3 times quantity x minus 6, where y of 5 is equal to negative 8. All right, so again, this is a separable differential equation, so I'm going to get everything with a y on one side and everything with an x on the other side. It just means leave x minus 6 on the right. So I'll divide both sides by y plus 3. So I get dy over y plus 3. Bring the dx across. So I have quantity x minus 6 dx. Put some integral signs. All right, on the left-hand side, I get natural log absolute value of y plus 3. It's very common when you're doing separation of variables to get a natural log. That happens a lot. On the right-hand side, instead of doing 1/2 x squared minus 6x, I'm going to treat it as the quantity x minus 6 and reverse the chain rule on that. So I'll get a 1/2 quantity x minus 6 squared plus c. Now, there's like 3 steps that I'm going to skip here because you skip them every single time. I have a lot of videos where I explain this. I'm going to go immediately to exponentiating. I will get y plus 3 equals a new value of c, e to the 1/2 quantity x minus 6 squared. So if you're not sure why that's happening, look at my other videos of what we do here. You basically always want to exponentiate before you solve for c if y is inside a natural log. And in the process of that, it's like you get the absolute value of y plus 3 is equal to e to the blah, which is really e to the c times e to the blah. And e to the c is just a new constant, and then you can get rid of the absolute value. There's a lot of steps going on there, but every single time it's the same process, so I skip those steps. And I recommend that you do also, but it's up to you. All right, we got to solve for c. So y of 5 is negative 8. Plug in. We get negative 8 plus 3 is c e to the not 0. Usually it's to the 0. In this case, it's to the 1/2. So we have negative 5 is equal to c e to the 1/2. If I divide both sides by e to the 1/2, it's totally fine to say that c is equal to negative 5 over e to the 1/2. I prefer to bring that e up to the numerator as e to the negative 1/2. So I will say c is negative 5 e to the negative 1/2. Now we're just going to go back and substitute in, right? So I do need to solve for y. I don't want to have like y plus 3. So I'm going to subtract 3 from both sides, negative 3, plug in for c, minus 5 e to the negative 1/2. Quantity, and then times e to the 1/2 x minus 6 squared. I had a lot of trouble saying that. You have e to the negative 1/2 times e to the 1/2 quantity x minus 6 squared. I'm going to combine those. They have the same base, so you add the exponents. So negative 3 minus 5 e to the 1/2 quantity x minus 6 squared, and then minus 1/2. I think that that's as good as you really need it. There's a little more you can do with the exponent where you like take a 1/2 out, and then you have quantity x minus 6 squared minus 1, and then you could expand that. There's a lot of options. I'm not going to do any of them. But anyway, that's going to be my answer. All right, let's take a look at the next one. A city has the shape shown, it should be above, but I thought it was a waste of space, so I moved it below. Below, with distances measured in miles, if the population density at a distance of x miles from the left edge of the city is x squared plus 1, find the city's population. Also, the population is probably measured in people. I realized as I was doing the problem that I hadn't stipulated that. It's best if you interpret it as thousands of people or hundreds of people, but whatever. We're just going to say that it's people per square mile, I guess. All right, so to do these problems, what I like to do is draw a rectangular strip within the city so that I can work out the area of that strip and multiply it by the density within the area, which will give me the people. So for my strip here, this is going to be delta x, and x is going to go from 0 to 5. So that's our delta x. The height of this rectangle is just f of some x value, right? Pick an x value within the range of that rectangle, and you can use it as a representative height. I'm going to choose the right endpoint because right Riemann sums are the way to go. So the area of that strip is just f of x sub I times delta x. And the area will be in miles squared. Now, density was given to us. The density is going to be x sub I squared plus 1. And I'm going to say that that's in people per mile squared. We get a weird answer when we do that, but that's okay. We also need to figure out what the function is. The function is just the line that goes from 0, 12 to 5, 2. So that has a y-intercept of 12 and a slope of -2 because you go down 10 and over 5. So f of x, our function, is 12 minus 2x. Also, I switched from using red, which I do not like the look of on this, to using gray. So I don't know. All right, so the people will just be, we need to add up all of these strips times their densities, right? If we do miles squared times people per mile squared, we get people. So the approximate number of people is the sum from 1 to n of the area, which is f of x sub I delta x, times the density. So f of x sub I times the quantity x sub I squared plus 1. We want to take the limit as n approaches infinity of that. We don't need to show that. That becomes our definite integral. So we're going from 0 to 5. Those are where the x values are. The function, which is 12 minus 2x, the density, and then dx. So now we need to solve this. I expanded everything, and then I reversed the power rule, and then I applied the fundamental theorem. When you plug in 0, it all goes away. When you plug in 5, you get 4 times 125 plus 60 minus 625 over 2 minus 25. When you clean all that up, which I use a calculator for, I got 445 over 2 people. So it would have been better if I said hundreds of people or thousands of people or anything other than some weird decimal of people. But that's okay. This is a density problem. I have a lot of videos on density problem. Well, not a lot, but I have videos on density problems. You can look those up if you're not really sure what's going on, because we haven't done a lot of those, but they do come up occasionally on the AP exam. So let's take a look at the next one. Find the equation line tangent to y equals e to the arctan of x at x equals root 3. All right, so this is a tangent line problem. We need to know what y is going to be equal to. So we'll get e to the arctan of root 3. So the arctan of root 3 is pi over 3, so we're just getting e to the pi over 3. I recommend that you memorize those values if you haven't already. I don't know. You got through pre-calc, math analysis, you should definitely know those values. But you might need to review them every once in a while. The derivative is e to the u times the derivative of u. The derivative of arctan is 1 over 1 plus x squared. We plug in here, you get e to the pi over 3 again, but then 1 over 1 plus root 3 squared. 1 over 1 plus 3 is 1/4. So we get 1/4 e to the pi over 3. And then we just need to write our tangent line. So y minus e to the pi over 3 is equal to 1/4 e to the pi over 3, quantity x minus root 3. It's ugly, but that's what the tangent line is. So that's the end of the problem set. I hope this was helpful, and good luck.